So for those that you have been to some of these conferences in the past, you've probably seen this machine mentioned before. Loccioni themselves, who were the manufacturer, they came along and did a presentation, I think, maybe a couple of years ago, just about how this has been developed. So just to give a bit of background as to why we're looking at this and what we're doing with it and how actually we're taking it forward. If we go back to when this sort of came across my desk, if you like, as a possibility system that we could look at, it was back in the days where we had, unfortunately, a couple of derailments that really were related to 053. So that was Bristol Street Gardens in Edinburgh and Shrewsbury. And the ORR and the RIRB reports that came out of those challenged Network Rail as a company to look at how we actually measured S&C, how we actually looked at the wheel-rail contact between the switch and rail in particular and the wheel against what we use now. So currently we're still using track gauges with P8 profiles on the top, and they're obviously the main focus of the moment of how we actually assess our derailment risk. But the ORR and the RIB during those investigations found that there's a lot of inconsistencies with 053 and how it was implemented in the first place. So clearly we had to go through an iteration of how we rewrote 053 to try and update it. We've gone through that again. It was reissued again last year. I wasn't involved this time, so I don't shoot a messenger this time. I did the one prior to that. But ultimately, we've still got this situation where we've got P8 profiles on track gauges, where people are using them. And perversely, we've got a situation at the moment where we've got 3 track gauge manufacturers. They all use exactly the same profile with exactly the same 3 lines on them. And when I was doing 053 rewrite, I checked the profiles that each manufacturer were using. They were all identical. But actually, we're still seeing behaviours, human behaviours that is, that actually it means you may have one manufacturer's gauge, they do the P8 profile check, and actually it fails to get another gauge from a different manufacturer, put it on there, and for some reason it passes. So it's more looking at which one's giving me the right answer I want, rather than actually what's the real answer that really we need to make sure we've got the consistency of doing the recording of this particular parameter and actually make sure we get the right answer that's consistent time and time again, instead of having this issue about which gauge am I going to use and whether I believe what it says or not. So I looked at Felix some time ago, probably about 2013-14, where RFI, who are the Network Rail equivalent in Italy, had commissioned Loccioni, who are a metrology company. They're not a railway company as far as at that point. They clearly are a bit more involved in railway now with this machine, to actually come up to design a method of actually doing a lot of gauge measurements and rail profile measurements using an automated system. So this machine is actually a robotic system. It's actually operated by somebody off track with a control panel. That means it can actually motor forwards and backwards on the track. It does all the actual measurements, which we'll go through a little bit more in future slides. And it basically takes away the human interface and makes sure the decision making that the software has already programmed is consistent time and time again. And once you've actually programmed the machine to run through a switch, you don't have to go through it step by step to actually allow it to find its own way. You can press a button and it knows what parameters it needs to measure. It knows which parts of the switch and the crossing it's at and how far into the switch and the crossing those changes of cross-section, changes of different parts of the actual S&C are. So it's a much quicker way of doing it. So basically we're looking at, obviously in this case, S&C gauge and geometry measurements, rail profile measurements throughout the S&C. So it's on anything that we have rail-wise through the S&C, which we've never been able to measure before, as far as the equipment we've had available. Looking at the wheel rail contact angle, looking at how we can make sure the measures themselves are actually accurate. And you can go back again in another week or two, do the same measurements, and you'll get exactly the same parameters being measured in the same place. So it's not a case of where you can put a track gauge on and you're roughly around the same area where you think you are before, and you're not exactly getting that repeatability. And it takes this human factor issue away. So this is where we sort of looking to try and basically get this on track to allow us to move away from the issues that were highlighted in the 2 derailments I mentioned earlier. And the ORR are still looking at how we're actually developing this, and they're keen for us to make sure that this actually happens and actually gives us the more consistent way of implementing 053 in particular. And also it has quite a reasonable speed of measuring, and it does an awful lot more measures than anybody can do in with a gauge in the same time. So this actually measures every 2 millimeters. So you can imagine trying to do that with a track gauge. It's obviously quite a lot more measures that we actually have available if we need to look at that detail. So going back into a bit of where we've been with this and so far, and I think it's really touching on some of the points we mentioned this morning about why does it take so long to introduce new technology to Network Rail. So 2013, as I said, I went out to Italy to have a look at this system being developed with Loccioni, just as a fact-finding mission at the time to see what was going on. They were actually in the middle of developing it at that point, so it wasn't the case it was ready to go. It was RFI that were leading that, and they were their lead customer, clearly, so we were just as an observer as to looking at how it was being developed and what parameters it was going to measure. So in 2017, I got some money together, and we managed to get some funding from the R&D pot to actually bring the machine over to basically just do a feasibility study on our track at Bletchley and at Waterloo Station through the Clapham DU, to really just show people what it can do, what's its capabilities, even though at that point it still was in the Italian format as far as what it was measured in. So that happened. Lots of people came out to have a look at it at various times. We had it for a couple of weeks, and a lot of interest in what it could actually achieve. And then it was a case of, okay, great, can we go for the next step? I've got £500,000 allocated to me to take it to the next stage. Went to CMP, having to go through the processes Network Rail has, and they said, you can't do that. Why not? Basically, it didn't allow us to actually give... CMP's point of view were looking from a point of competition to making sure we'd given anyone out there in the industry, not necessarily with the railway industry, just industry in general, to have an opportunity to propose to Network Rail how they could actually achieve the same thing. I'd actually gone through a system of process that we had to do for actually getting the feasibility study to allow us to do that with what they call a prior information notice, which goes out through our contracts people to get interest from, again, the same sort of areas of industry to try and give us a view of what was out there. So we could see where we actually were pitching this particular machine against anything else that might be available to give us the same output. So that wasn't good enough. And we said to the CMP at the time that we know we're going to be back at Loccioni at the end of the process you're telling us we have to go through, because there's no one else in the world does this in the same format that this machine does. They weren't having any of that, so we had to go through the full OJU process in 2018 and 19, even though we weren't actually contracting Loccioni at the time to buy anything. All we wanted to do was develop a system that actually met our requirements. But because of CMP rules, unfortunately, we had to go through that process, because if we bought 1 or 2 machines, for argument's sake, at the end of that process, it will go over the OJU limit, which is 320, I think it was at the time, £320,000. And that meant we had to go and put this out to the official journal of the European Union to basically have the whole process allowed to actually just go through. And it takes over 9 months, but it took us 12 months eventually to get everything in place. And guess what? We ended up back with Loccioni, which we knew we would. CMP wouldn't actually give us any leeway in any shape at all. So we had to go through the process. I wouldn't say it's a tick box exercise, but it's an exercise that they had to prove we'd done the governance. So if anybody challenged us in future or decided that we didn't give them an opportunity, we could prove we actually met everything that we were supposed to. So eventually, last year, we got a contract with Loccioni, and now we've managed to get onto phase 2, which is really just not developing the machine to the point where we're changing a great deal of the machine's capabilities. It's just actually getting it to work on our infrastructure. So that's started. We've got the machine over at the moment, doing some testing on recording through different switch types, switch designs that we have. Because unfortunately, within Italy, they've got about half a dozen different switch designs as far as length designs, as in we've got bullhead, flat bottom, shallow depth, etc. Italians haven't got that issue. Yet when we look at ours, we had to look at least 35 different switch types, and that's the design as well. So ultimately, we had quite a lot of work to do to try and look at how we did manage to record all this. But before we got to that point, we had to get through the product acceptance to get the trial certificate. So as part of the contract with Loccioni, we had to get them to go through an engineering certificate of conformity, which basically means that rail industry standard 1350 there is for bringing new plant onto our infrastructure. But obviously, we had to make sure that whatever requirements were in that standard, the Loccioni Felix system met those. A bit of a quirky situation, really, because the plant's standard was more for things like on-track plant or trolleys. And this clearly fit in the middle somewhere. So it was a case of, well, we'll have to actually look at seeing how actually we can adapt those standard requirements to what the machine said, what the machine could do. So Loccioni had S&C Lavalin working with them to get this engineering certificate of conformity sorted out. Quite a lot of work going into that to get that available for us to do. At the same time, as part of the product acceptance, we had to look at all the ergonomics about how we lifted this, how actually was it something we could actually put on track. So the actual machine itself, I haven't got a slide showing this, but it's basically in modules. So there's 6 different modules for it, and each one weighs, I think the highest weight is around about 50 kilos. And it takes, to actually take it to track and get it on track, once you've got line side, about 2 minutes to put it together. And then you're off and running. So it's quite a quick and easy system to take on track to actually allow us to get some work to be started. So to program the machine, as I said, we looked at our plethora of different designs from the S&C types we have all over the different areas, so bullhead, flat bottom, shallow depth, NR60, etc. And we tried to narrow it down as much as possible so we can look at our most common types of switch, and they're the types that we came up with. So we've gone through those different designs to look at how we can try and record as many of those different lengths of switches and program the machine to recognize those switches and then have that available for the future. The problem with our designs is that sometimes we haven't got things that are quite standard. So we have standard RAPW drawings telling us what the design should look like, but clearly when it goes to a particular site, it might mean that it's not quite as it should be in this bespoke for the design. For example, the check rail. There's a standard length of a check rail on the actual RAPW design, but clearly when you go to a site, the check rail might be in a slightly different position, or it might be slightly longer than the design was actually saying on the RAPW. But the machine needs to know that. It needs to know where the start and finish point of that check rail is. Clearly that means we may have bespoke requirements for programming the machine when it gets out on site for the first run only to get those parameters put in the machine. But once it's actually there, you can go back time and time again, press the button saying it's switch type X, and it will go through that switch and record all the parameters it did before, and then you can have that data available. So to record a particular switch in the basically through route and the turnout route, roughly, if you've got everything set up correctly, it takes about 6 minutes. So it's very, very quick. And as I said, it measures at every 2 millimeters. So you can imagine the amount of data that's creating. So this is what the actual configuration of Felix itself had when we started looking at it. So this is the Italian version of what we're sort of mirroring in a way. So these are the sort of measures that the Italian infrastructure maintainer asked Loccioni to be able to measure. So we've obviously got similar requirements, but not quite the same. So we've had to look at how we need to tailor this to our needs. So we've identified a few areas where we do some measurements at the moment, which we need to have in this area, which looks at things like the seating gap. So the hogging, if you like, which people look at the gap between the switch rail foot and the slide plate, if it exists. Because obviously, if we use a P8 profile now, we have to accommodate that particular gap. Clearly, this machine is only a 250 kilogram weight, so clearly it's not going to be dynamic. It won't push the switch down that far. So we need to try and factor that into the measures that it takes with the P8 profile that it's got in its software. Squareness of switch toes, again measuring how we can detect where they are in relation to each other. Residual switch opening, which could be a problem or not, but obviously that's something that we're interested in measuring, which we do as a general rule. Obviously the P8 profile itself, which is clearly something that's more bespoke to our requirements because of the wheel profile we use as our switch derailment hazard checks. Gauge 1 and 2, which is looking more on side wear and head wear on the stock rail and the relationship between the wear on the switch rail as well. And back-to-back gauge measurements. So those that are familiar with what back-to-back gauge measurements is, Neil Denton, when he was still working for Network Rail, came up with this great idea that if we wanted to measure an S&C switch in particular, and we thought we got wide gauge, is it wear on the switch rail or is it actually wide gauge? Don't really know. Some people out in maintenance were getting a bit confused about seeing wear on the switch rail and confusing that with wide gauge because of the reading they're getting on their gauge. So Neil came up with an idea of having to measure the outside edge of each rail, each stock rail, and go through the whole switch to find what those measurements look like, which give us the exact data as to whether we've got white gauge or whether we've just got some switch wear. So we've now actually asked them to do as much as we can with the back-to-back gauge measurements. Clearly, with the width of the machine itself, there's a limit to how much we can do with back-to-back gauge measurements, but we've got quite far into the heel of every single type of switch we can do. Clearly, the shorter switches, which have got the highest rate of change in switch radius, are the more difficult ones to actually measure because they actually diverge much, much further than a longer switch. So they're the measures we've basically challenged Loccioni to have a look at, and they've accepted that they can actually look at all these, and they are working through these individually to get those measures of something we can actually use on the machine once it's completed its development phase. As part of this, we've obviously gone out to different DUs. We've had a lot of support from them to actually allow us to put it on track and go through switches in their DUs. At the same time, having the ability to go out with the actual 053 inspectors at the same time, so we can check what the machine shows us against what the inspectors are doing. So you can see in this picture, they're doing both the P8 profile check and they're actually using a mini prof at the same time, just to get a bit more idea about how close things are within the machine that we're talking about, the Felix, and the mini prof, which is obviously very accurate in relation to what it's showing. And Mark Bostow developed some, from the Vehicles Dynamics team, software that actually meant he can put the P8 profile on top of what the mini prof shows you and tell you exactly what the contact point is. So we asked Loccioni to overlap the mini prof readings with what the Felix is actually measuring. And this is just a snapshot of one of the actual areas where we've had some data back from Loccioni looking at the actual combination of the mini prof and where Felix says the actual P8 profile contact is. And as you can see, if you can read that quite easily, the actual contact is very, very similar in correlation to what the mini prof says. Apart from the fact that actually the Felix is much more accurate in relation to the, it can go to 3 or 4 decimal points. The mini prof can to a point, but clearly if you try and do a mini prof every 2 millimeters, you can imagine how long it's going to take you to do a full switch, whereas this does this in about 6 minutes. But clearly, the correlation between the two systems is quite important to be able to prove that, and it's useful to understand exactly where that sits relative to the P8 profile lines as to whether it's a pass or a fail. So again, this is just information that we're trawling through to make sure it's got the repeatability and the reliability of these measures that we're taking on each switch type. And just as a aside, we haven't developed everything yet from a point of view of what we see as a format which we'll have on an iPad or an app in future. But this is something Loccioni came back with from a particular site where these represent the 3 lines on the P8 profile, and obviously the dots you can see are where the actual contact point actually was measured by the actual the Felix system. So clearly, from that point of view, it's quite quick and easy to see where the issues maybe need addressing, or in this case don't, that we've actually got some quick and easy way of looking at seeing what that issue may be that we need to see from the P8 profile contact point. Again, this is just work in progress, but it's looking at, this is a sort of a butchered version of 3068, which are gauge management measurements that we do through our switches. And this is looking at those parameters that we saw on the previous slide about the RFI points within the switch that we can measure. So this is sort of similar data to that, and it's obviously showing you to 1 decimal point to actually what the accuracy is and how far away from the switch toe into the switch that measure's been taken. On the left-hand side, it's the right-hand side, sorry, showing you the actual just 3 different possible measurements that we can actually take from this. Looking at gauge, clearly that spike there is something people might be familiar with when you come to the crossing nose, which obviously means there's a gap, so the laser itself just sees nothing but a gap, there's no rail there, hence the spike. The switch opening, that's basically the gap between the switch rail and the stock rail when it's open, and the back-to-back gauge, which is obviously as you go further into the heel of the switch, the rails are diverging, and that's the sort of reading we can get from that. We're also obviously looking at various areas where we've got complex junctions. How do we program those? Clearly this is a fixed diamond double slip at Waterloo Station, but it's just looking at those where we've done some recording of the actual main types that we see, that we have particularly being able to get access to. So double slips, single slips, fixed diamonds, tandems, and scissors crossovers. So there's quite a lot of work done in to try and program the machine to actually be able to do a run through each of the actual options of where the actual train could be diverted. The ergonomics interface, we've obviously got to look at how we make the form when it comes to putting it on an iPad, what it looks like, even down from an ergonomics point of view, what the font looks like and what colour it is. So you might think, well, that's a bit extreme, isn't it, looking at the actual detail in that sense. Well, actually, from the ergonomics people, they've said it's one of those areas where you take for granted what the colour looks like, what the font looks like, and actually it can turn people off if it's not easy to read or the colours are a bit glary. You've got to be a bit careful about how you actually interact with that person, so you actually engage with them as much as you possibly can, even through that sort of detail. Obviously, how the information is captured, what do we do with it, where does it go, where's it stored? And the one thing that we've not asked for, but we'll be following closely, is that Loccioni have been asked to develop an app for, I think it's an Android system at the minute, but they're looking to do the same for an Apple iOS system, which obviously will be very, very useful for ourselves when it comes to actually deploying this equipment. So phase 2, we've got quite a large amount of work still to do. There's all those aspects to do. The two that I've highlighted there, liaise with the asset management information people to store the data, is another one big task. And carry out the common safety method risk assessment is another large task which we've got to go through to get this proven, to say, if we're especially looking at actual switch derailment issues, how we actually can say that this machine is going as good as, if not more accurate than what the actual current methods are. And obviously we'll eventually get to the full acceptance point of view. So we have quite a few challenges still to face, to go through, to get to this machine being available to go and put it on track and say to maintenance, here's a load of training package, go away, learn how to use the machine. It's yours to actually use and get the best out of, and we'll obviously help them with business change, etc., to try and make sure we actually make sure that each individual route and region gets the machine to do what they need that meets their needs, rather than actually a one-fits-all approach. One of the bigger issues for us, which we've got to just highlight, is the calibration of the machine. So the top two photos, show how it can be quickly checked in the field to understand that the head that does the measuring is still accurate. That's something that maybe is done every so many shifts, just to make sure that the machine is still reading correctly, quick and easy, not an issue with that. However, when it comes to the actual process of looking at the whole machine and how we calibrate that as a requirement, you need a dynamic test rig, a static test rig that's in there, and it's got to be done within a calibrated dynamic test house. So we've got quite a lot of areas where we need to make sure we engage with a particular calibration company to be able to buy those rigs, give them to them perhaps as network rail own them, and they actually provide the service to all the people who actually have this machine. So again, quite a task. So the future. This is a machine that I went out to see with Kevin Hope, who's in the audience, for looking at an S&C Dynamics solution for looking at the same measures effectively. And that little photograph on the left-hand side at the bottom there with the little bubble pointing to the machine, that is the pod that's got the Felix system in it. So Loccioni have basically made a system that can go on a train and do exactly the same thing. So clearly there's a potential for us to have some synergy there if we bring the Felix in, to have the same system put on a dynamic vehicle of some sort, or something similar that actually means we can record the same data, whether it's from Loccioni or another company. So we get the dynamic data, and obviously we can use, as we're showing on the right-hand side, the vision system, so we can actually look at how we can incorporate PLPR for S&C effectively. So that's the future, and that's something that's not a project I'm leading in any way, but I'm involved with the actual specification for what the system should actually be able to measure, which is obviously going to be similar to what we've talked about with the Felix system. And that's a quick run through how we are going with that project.